Hi, this is Alan with Bothell STEM Coach, and today I wanted to talk to you about proofs. In a normal curriculum, you'll learn about proofs in a geometry class, so you'll be proving a lot of different things about different angles and different shapes, but proofs are really powerful and really important in not just geometry context, but in all kinds of branches of mathematics. And so I wanted to go through a really interesting proof that doesn't require a lot of background knowledge, but is not a trivial proof because it's not immediately obvious that something is true. Whereas sometimes when you do geometry proofs, it's sort of like, okay, I know this is true. I just got to outline the steps to make it true. So I wanted to talk about when the square root of 2 being an irrational number. Now, to be an irrational number means that the square root of 2 cannot equal some fraction where m and n are integers. So the converse is a rational number. Rational number means I can write it as a fraction where the numerator and denominator of the fraction are integers. Okay, so like 3/4 or 6/8, those are kinds of fractions in rational numbers, but square root of 2 is not, because presumably it can't be written that way. But anyone who maybe have been inquisitive is just like, well, how do you know? How do you know there isn't just some weird number that when I just happen to square it, I get 2? Like, how do you know? And that's where proofs come in, is where we have to prove something to be true to know for certain that it is false. So let's take a look. There's a lot of different techniques for doing proofs, but one of them powerful way is to do by proof by contradiction. And that is where we assume something to be true, and if we follow to its logical conclusions and find that it's impossible, then whatever we assume has to be false. So let's go through an example. We're going to assume that there is such a fraction that exists where m and n are integers. We're going to pretend that one exists, and we're going to see if we run into a contradiction through this. We're also going to assume that it's in reduced form. That means the fraction has eliminated all of the common factors. So like, as an example, when like 6/8 is not reduced because that reduces to 3/4, right? These are two equivalent values, but we're going to assume that whatever fraction is, we've eliminated all the common factors, and so we are as simplified as we can get. Sometimes we call it a simplified fraction. So we're going to assume that this is true, and then what other things do we know to be true because of this? Well, we know that if we square it, both sides, that we should get 2, right? So this should be m over n squared. That's what the square root means. It means that if I square it, I get 2. We know that if I squared it, this would equal m squared over n squared. Now if I rearrange it, I would get 2n squared equals m squared. Okay? Now we have to think about what this means. What does this tell us? It tells us that m squared is even. What does it mean to be even? It means it's a multiple of 2. So we know that because it's 2 times some number squared, m squared must be even. And if you think about squaring, we have some rules that when we multiply, right? M squared is m times m. And if m were odd, an odd number times an odd number is an odd number, and an even number times an even number is an even number. So because m squared is even, that implies m has to be even. See, m can't be odd, right? Because if m were odd, then m squared would be odd, and hence it would contradict with everything we know so far. So we know m is even. So that means m can be written as 2 times some other number. K is an integer. Because that's what it means to be even. Okay? So now the trick I'm going to do is I'm going to put this back into this equation. So I get 2n squared, and instead of m squared, I'm going to say it's 2k squared. Why? Because m is equal to 2k. This is equal to 4k squared. So I have 2n squared equals 4k squared. I can divide both sides by 2, and I'll get n squared is equal to 2k squared. Now what does this tell us? This says n squared is even. And by similar line of logic before, that means n is even. Okay, and you might say like, oh, interesting. So let's look at the statements that we know to be true now, that we've assumed that there's a fraction. We know m is even, and we know n is also even. But what did we start out with? We started off assuming there's a fraction, and we also we assumed that it was already reduced. If they're both even and they both have factors of 2 left in them, that's not reduced. So this statement here, combined with this, is a contradiction. This cannot be true because we've established from the beginning that this was assumed to be a reduced fraction. So, because we reached an impossible contradiction, I misspelled contradiction terribly, forgive me, contradiction, because we've reached a scenario where both things is a contradiction, it cannot happen, our assumption must be false. Hence, square root of 2 cannot equal m over n for any integer. And that proves that the square root of 2 is irrational. Okay? Again, we didn't start off knowing for sure that it's irrational, but this logical line of reasoning outlines why it must be true that the square root of 2 cannot be written as a fraction, and hence is an irrational number. Alright? So I hope you enjoyed that. Leave a like if you did enjoy it, and subscribe to see more videos from me, and I'll see you guys later.